Welcome to the Insightful Professor. In our previous video on subquery, we introduced the concept of a subquery by saying it was a select that could be nested or embedded within another select. The syntax for including the query required that we enclose it within parentheses. That made it similar to an arithmetic expression, which would then be evaluated by working from inside the parentheses out. The same we said was true of the evaluation of a subquery. The subquery would execute, return a value. That value would then be passed into the main query. It was a case of execute the subquery once, we're done with that. Execute the main query, we're done. We're now going to talk about a variation on the subquery called a correlated subquery. Although the syntax will look similar to what we saw with the previous examples of subquery, the behavior will be quite different. In this case, we'll have a subquery that will execute not once, but once for each row that will be processed in the main query. Rather than jumping right into an example of a correlated subquery, we're going to attempt to ease into this by building up some background information. First, recall that a subquery could return more than a single value. In the example that we're showing here, the subquery will identify those departments that are located in the humanities building. Turns out that in my database, we have more than one such department. Therefore, more than one value will be returned by this subquery. Now, in this case, the subquery will return philosophy, and it will return theology. These two values will occupy separate rows in the result set, or in the resulting table. We use the term cardinality to refer to the number of rows in the results set or in the table. In this case, we're saying that the cardinality can be greater than 1 for a subquery. We've already seen that, we just hadn't formally expressed it using this term. There's another concept that we did not discuss with respect to the characteristic of a table, but also with respect to the behavior of a subquery. While cardinality refers to the number of rows in the results set, the degree of a table or the degree of a relation refers to the number of columns or attributes. The degree of a result set can also be greater than 1. All of the examples we've presented thus far have returned a single column, hence the degree has been 1. We've now indicated that the degree could be greater than 1, and we'll examine that in our next example. So another way of phrasing this would be that each row returned by the subquery could contain more than 1 column. Let's suppose that we wish to compare the courses offered by one academic department with the courses offered by another department. We want the courses with the same combination of credit and lab fee values. That's our criteria. Thus, if one department has a 3-credit course with a lab fee of 0, we want to determine whether the other department also has a 3-credit course with a lab fee of 0. In the following query, we identify the credit and the lab fee combinations for philosophy department courses. But what we're showing is within each row, the credit value for a course and the lab fee value for the same course. What we want to do is look at courses in another department, something other than philosophy, and see whether any of the combinations that appear in this result also appear in rows for the other department. Now, because a subquery can return multiple columns, that is a degree greater than 1, as well as multiple rows, a cardinality greater than 1, we could pass the result set of this query into another query. Here we're using the query that we just showed as a subquery. Remember, it is returning 2 values in each row, credit and lab fee. Because multiple values are being returned in each row, when we receive the value in the main query, we must compare multiple values. It just so happens that the course table is being accessed in the subquery and the main query, so we're using the same columns. Credit and lab fee are being compared to the credit and lab fee values being returned by the subquery. This is a real powerful mechanism. When I was first working with Oracle database back around Oracle version 5 or Oracle version 6, what we saw was this feature was supported. But at that time, this capability was not available in IBM's DB2, nor was it available in Microsoft's SQL Server. So it was a feature at one time unique to the Oracle database. It has since then been adopted by other software vendors. Now note that the query we just showed is a single subquery that returns multiple rows, multiple columns. This is not the same as having two queries as subqueries, where one returns the credit value for philosophy department courses and the other returns lab fee for philosophy department courses. These two queries, as shown here, are independent of one another. Our goal was to get the combinations of credit and lab fee, not simply to get a credit value of some philosophy course and a lab fee value of some philosophy course, possibly a different course, but we wanted the credit and lab fee values from the same course for philosophy to compare against other departments. Let's examine precisely how the queries that we just discussed operate in the database. First, we wanted to display the credit lab fee combinations that would be returned by the subquery. So here we're taking a look at select credit lab fee from course where the department is equal to philosophy. Remember, these are the two values that will be returned from the subquery to the main query, and these are the same two values that we'll be looking for in other rows. So let's see what else is in the course table. Okay, in the course table, what we see is looking at credit and lab fee combinations. Would be these columns here. What we wish to do is look at another department and see if the combinations are present. So here we have, for CIS, these combinations. Do any of these match the combinations that we found in philosophy? Do we have a 3 and 100 combination? Turns out we do. Do we have a 3 and 50 combination? There's another one. So we have multiple combinations of credit and lab fee that exist in philosophy that are also present in CIS. What about in the theology department? None of the theology department courses have a corresponding credit lab fee combination, but CIS does. So now what we're going to do is see what happens when we run our query. So here's the query that contains the subquery that returns multiple columns. And sure enough, what is returned would be the CIS rows that we just identified. Notice that we have excluded philosophy department rows from the result of the main query, because obviously philosophy department courses will match the credit lab fee combinations of existing philosophy department courses. So we exclude those from the main query to identify and reveal courses from other departments. Now let's consider the other option. We had said that if you had these two individual subqueries, this would not yield the same result. Let's verify that by running this query. And notice we do not get the same 3 rows, we get a total of 7 rows. And we're producing some rows from the theology department, but clearly we had indicated that no theology department courses had the same credit lab fee combination found in a philosophy department course. The reason for this difference in the result is that these subqueries are completely independent of one another. We're testing to see if the credit of any philosophy department course is equal to the course that I'm looking at now. Is the lab fee from any philosophy department course equal to the lab fee in this course that I'm looking at? But we're not necessarily getting the match from the same row or from a single row in the philosophy department. We're now ready to discuss a correlated subquery. Now, a subquery often has no interaction with data in the main query. The subquery simply communicates the data that it retrieves, whatever value or values it finds, and returns those to the main query for processing. This type of subquery executes once, and it's done. But sometimes the information being obtained through the subquery is dependent upon the data currently being processed or considered for inclusion in the result set of the main query. In this case, we say that the subquery is correlated with the main query. Thus, it's a correlated subquery. A correlated subquery is a subquery that uses data from the main query to determine its output, its result. So a correlated subquery, instead of being executed once, must be evaluated for each row that is identified for processing in the main query. So with a correlated subquery, data from the main query provides a context for the execution of the subquery. A correlation variable is used with a correlated subquery. This correlation variable could be explicitly declared within the main query. It is used to identify the current row within the main query, which will then establish the context for execution of the subquery. It's used to qualify a reference to the data being passed from the subquery to the main query. In addition to referring to this element as a correlation variable, it's also been called a table alias because it's an alias, an alternative name for a table. The correlation variable thus serves as a kind of a pointer as the processor works its way through the rows of the main query one at a time. Each time there will be a call to the subquery passing data from the current row, the one being pointed to or referenced by the correlation variable. In this query, we are using a correlation variable that we called CX. So in the main query, we associate this identifier or this variable CX with the course table. In the subquery, we say select the max lab fee from the course table where the department is equal to cx.cdepartment. In this type of subquery, it's not possible to execute the subquery in isolation, that is, as a standalone query. Because of this relationship or this correlation to the main query, we have to receive from the main query a value for cx.cdepartment in order to complete the predicate in the subquery. So cx.cdepartment refers to the cdepartment column of the row currently under consideration in the processing of the main query. After the current row has been processed, CX acts kind of like a pointer and advances to the next row being considered in the main query. This will cause the subquery to be evaluated again, but with a different cdepartment value, the value from the current row. So in effect, for each row in the course table in the main query, the system must examine the cdepartment value of that row, execute the subquery to determine the maximum lab fee value for the department for that row, and finally compare the lab fee value from the row under consideration in the main query to see if it is equal to the value returned by the subquery. If the values are equal, this row pointed to by CX will be included in the output of the overall SQL statement and be presented for display. But regardless, CX will then advance to the next row. Sometimes a subquery is used only to determine if there are any rows in a table which satisfy some condition. In this case, the main query can use the exists keyword to test whether any match in a condition is present within the table. If the subquery finds at least one row, the exists test results in a true condition, and the row whose column value caused the match is selected for display. If the subquery does not find a row, the test results in a false condition, and the row whose column value was used to test for the match is discarded. This is the principle of cardinality that we were discussing earlier. Effectively, the subquery either finds something or it doesn't find something. All the subquery needs to find is one row that satisfies the condition. So if the cardinality of the subquery is greater than 0, that causes the predicate that relates the main query to the subquery to evaluate to true. The query presented here identifies those staff members that are currently assigned to a department recorded in the department table. So we're selecting rows from the staff table where there exists a row in the department table that has a department ID equal to the department ID of the staff member. Now the correlation variable here is the name of the staff table. In the subquery, staff.dept is referring to the DEPT column in the staff table, which is the table referenced in the main query. We're able to use the table name rather than introduce something like we had used previously, like CX, for example, because the table accessed in the main query and the table accessed in the subquery have different names. Now, a correlated subquery can also be formulated using not exists, and this will allow us to select rows which would not be selected by the exists condition. So here we're selecting rows from the staff table when there is no matching department in the department table. Let's take a look at a couple of these queries on the database and see how they actually work. Here is the first query that used the exists keyword. We've identified those staff members such that there exists a row in the department table with the same department name as the department name to which the staff member has been assigned. So we're seeing employees assigned to theology and philosophy. Let's take a look at the content of the staff table and of the department table to better understand what's happening here. I have a second SQL Plus display open, and I'm going to use that so that we can continue to see the result of this query and look at the content of the tables that were involved. In the department table, we see 4 different departments: theology, CIS, management, and philosophy. Our objective in the correlated subquery was to retrieve rows from the staff table, provided that these staff members were assigned to departments present in the department table. So we can see that for the staff members that were returned, clearly their department IDs are found in this list of valid department IDs from the department table. Let's consider the additional staff members. We also have a staff member assigned to math, another to engineering, and another whose department ID is null. These three staff members, Euclid, Archimedes, and Da Vinci, do not appear in the result of the correlated query. And that should make sense because their department IDs were not found within the department table. There's another way to consider what we're doing here. We're doing existence testing with a correlated subquery. If you think about it in terms of the way I was describing it here, it sounds as though we're doing a set membership. Let's consider this for a moment. This query selects rows from the staff table, provided that the department ID of the staff member is present in this list of values returned by the subquery. So here we select all of the department IDs from the department table and examine those values one by one using the in operator. We're looking for something that is equal. And we find the same data is returned by this query that was returned by our correlated subquery using the exists operator, or the exists keyword. So as it turns out, exists and in behave in a similar fashion. Now, if that's the case, what happens if we use the not keyword? And we take this query and revise it such that we're going to say select from the staff table where the department, but we don't want to say in, we want to say not in, and use the same subquery. Our goal here would be to identify staff members whose department ID is not found in the department table. And notice that we get Euclid and Archimedes, but recall that we had Euclid, Archimedes, and Da Vinci. Da Vinci doesn't show up, and the explanation should be clear. When you use in or you use not in, you're doing a comparison of equal or not equal. And if the department ID for Da Vinci is null, it's not going to satisfy either the test for equal or not equal. So we don't get Da Vinci. Now, let me show you not exists. Observe that the Da Vinci row appears in the result. This is not doing a test for a value being equal or not equal, because the subquery is not actually communicating any values back to the main query. It's simply giving a reflection of the cardinality of the number of rows identified by the subquery. To make sense of what's going on here, let's consider the data in the staff table as shown on my display. We'll start by assuming that the first row being processed is this row for Luke. What we're doing is we're going through the main query, selecting from staff where, because it's a correlated subquery, we'll take the rows one by one, and we're assuming that Luke is the first row. From that row, we will pass the department ID of this staff row into the subquery. Select asterisk from department where department DEPT is equal to, and here we're saying theology. This is the subquery where staff DEPT has been replaced by the value of theology, the department value from the row for Luke. Now, when that executes, what's going to happen? You're looking for a row in the department table where the department ID is theology. You're going to find such a row. Such a row exists. If we test for exists, the subquery finds more than 0 rows, a cardinality greater than 0. Thus, rows as described by the subquery do exist. If we test for exists by saying where exists, then we're expecting to find rows. We did find rows, so the where clause evaluates to true. But in our current query, we're looking at not exists. So now, when the subquery executes, it will find rows. However, we tested for not exists. Our expectation was there are no such rows, or we made a claim you're not going to find anything like what's described here. When we found something, it conflicted with our expectation or our claim, so our claim was invalidated, which means that the where clause evaluates the false. That's why when we run this query, we don't see the row for Luke in the output. The same is true for Mark, Matthew, Dick Nix, Hank Kiss, and John, because when we use their department IDs to fill in the value for staff DEPT in the correlated subquery, we found something. The where clause said you're not going to find something. It claimed not existence. But when we encountered the row for Euclid, what happened was we had a value of math, and when we say go look in the department table for math, we didn't find a math, so no row was found. Our claim that you wouldn't find a row became true, hence Euclid appeared in the result. And the same processing applies for the Archimedes and Da Vinci rows. Now that we've discussed how exist and not exist work, let's consider another example. In this particular query, the goal is to display information about a course that has a unique lab fee. What we mean by that is if a course has a particular lab fee value, then there can be no other course listed in the course table with that same value. Here's a correlated subquery that achieves that goal. Let's go into the database and dissect this. Looking at all of the courses in the course table, we examine the lab fees and we see there are several courses that share a lab fee of 0, multiple courses with a lab fee of 50, and likewise 100 and 200. But there are some courses who have a lab fee that no other course has. Here is a lab fee value of 90. There's a single course with that value, a lab fee value of 150, and a lab fee value of 500. Let's look at how our correlated subquery identifies those three rows. When we execute this correlated subquery, we see those three rows are returned. Let's look at how this is accomplished. Remember, in the main query, the where clause must evaluate to true for a row to be returned. We're using not exists. So in the subquery, we're probing the table, looking in the course table, and notice it's the same table, course. So we're using two correlation variables to distinguish a reference that originates from the main query or the outer query from a reference that refers to the course table in the subquery. The subquery is looking in the course table for a lab fee that is equal to the lab fee of the row from the outer table. The second condition is quite important, because if we take a lab fee and we go looking in the same table from which we've extracted the lab fee, we're going to find it. The row that provided the lab fee, in this case the C1 row, has that lab fee value. So what we have to do is we have to exclude that row from consideration in our search. Because when you go looking for something that resembles you and you're in the crowd, you're going to find yourself. So we have to exclude that match. CNO is the primary key of the course table. So we're saying that the primary key of the row C1, where we got the lab fee that we're using to search, that can't be the primary key of the row where we found the match. So what does this subquery do? It's looking for a row that has the same lab fee, but is a different row, has a different course number. If we find such a thing, then we found somebody who shares our lab fee, hence our lab fee is not unique. Our goal is to do this probe and not find anything. If we don't find anything, if we don't find a match, then our lab fee is unique. That's why we chose not exist. Our final example of a correlated subquery brings us back to our original question, the question that we posed when we started this video. What we wanted to do there was to identify courses from all departments that offer some course with the same credit and lab fee combination found in some philosophy department course. We did that in a very different way in our first approach. We're now showing a solution that uses a correlated subquery to achieve that same goal. So here we're selecting from the course table and excluding philosophy department courses. And then we have our condition where we're looking for rows in the course table that are philosophy department courses, and the credit of those courses is the same as the one that I'm looking at now, C.credit, and the lab fee is the same as the one I'm looking at now, C.lab fee. So that's where the correlation comes in. So I'll leave it to you to review what we've talked about and verify the accuracy of this query. So what have we discussed in this video? We initially showed a subquery that returned multiple columns. Remember, the number of columns is referred to as the degree of the table or the degree of the relation. We explained the idea behind a correlated subquery, and we distinguished a non-correlated subquery from a correlated subquery, explaining the characteristics of each. We discussed the use of exists and not exists in formulating predicates to relate a main query and subquery result. I hope you found the video informative. I know the topic is a bit difficult to grasp at first, but I believe we've touched upon the key points to clarify how these things work. And once again, thanks for watching.